Alright guys, let's try this out and see how it goes. If you hate it, we never have to do it again. If you like it, well, I'm glad. Alright, so let's give this a try. This is something I wanted to do in class, but we just didn't have time, and I feel like it'll be helpful on the exam. I am just recording this on my phone. You guys should have this page already. It's page 956, and let's fill this out together. So when the argument is unknown, that means that you're not sure what goes in this parentheses here. So you got two options. You can either rewrite as exponential first and then solve for x, or do change a base and then solve for x. So one of these is going to be what I consider a preferred method, and one of them is going to just take a little bit longer. You'll still get there, it'll just take longer. So first one, let's say here I just decide to write as exponential. That means 5 to the 3.1 power equals x. Well, now I can just take that to my calculator, right? 5 to the power 3.1 and then approximate. So once I go to my calculator, I see x is approximately equal to 146.83. So I'm going to go ahead and say that this is the preferred method when it comes to unknown arguments. Set it up in exponential and solve. I will show you change a base anyways, but there's more steps. So if I were to do log of x over log of 5, and that comes straight from here, from change of base, equals 3.1. Well, now I have to multiply by log of 5 on both sides. And then I have to put this in my calculator and convert back to exponential form. So then I would have 10 to whatever this approximation is. And I believe, if I'm correct, it's 2.167. I don't have a calculator here with me right now, but that would be approximately x. And then we should get the same answer, 146.83. So like I said, this is going to be the preferred method. This one just has a lot more steps, a lot more opportunity for error, and we don't want to run into any issues. So this will be the more straightforward method. Okay, and I put a little star right there to remind me. All right, let's try another. Oops, sorry. When the exponent is unknown, so you're not sure what the logarithm is equal to. Well, let's take this one. We would go 8 to the x power, and this is me rewriting first and then solving for x. So 8 to the x power equals 145. Now I could take the log of both sides. Sorry if you hear the other teachers in the other rooms. Properties of logarithms tells me that I can take this x out to the front. Remember, walking the dog. X log of 8 equals log of 145. My last step, since this is multiplication here, I can just go ahead and divide. Log of 8, log of 8, that cancels. So x is equal to whatever this is, and so since I go in and put that in my calculator, I end up approximating, and I get x is approximately equal to 2.4. So not too bad. I converted to exponential form, like it said, and then I took log of both sides and divided. Okay, let's see what that looks like if I were to do change of base first and then solve for x. So change of base here tells me to take log of 145 and divide log of 8, and that's going to be equal to x. So as you can see, I already got to the same place I had gotten earlier with way less steps, and I can just say x is approximately 2.4 once I take that to my calculator. So I'm going to put a star here and say if I don't know what my answer is to the logarithm, I'm going to go ahead and do change of base and solve for x, because that's just going to be less steps for me. Alright, so that's 2 done. The last one is, what do I do if I don't even know what the base is? Right? And I'm going to be honest with you here. I am I'm not likely to ask you a question like this, but I want you to know how to handle it if you do run into something like this. So, I would just go ahead and put it in exponential form. X to the 6.7 equals 24. Well, I know how this means x to the 6.7 power. Well, if I just go ahead and take that and put it to the 1 over 6.7 power, it's like taking the 6.7 root, right? But I have to do that to both sides. Then here, this just cancels out to 1. X to the 1 equals 24 to the 1 over 6.7. And this is a calculator problem. Let's go straight into my calculator. 24 to the power of 1 divided by 6.7. And I should get x is approximately equal to 1.607. Okay. This, I'm going to tell you right now, that's going to be the preferred method. This one just has a lot more steps. If I were to do change of base, log of 24 over log of x equals 6.7. Whoops. Well, now I got to multiply by log of x on both sides. Sorry, it's hard to write and record. Now I got to divide by 6.7. It's kind of like if I cross multiplied. So I got log of x equals log of 24 divided by 6.4. That's going to go in my calculator. And I'm going to end up getting approximately 0.2, whoops. Approximately 0.21. And so then I have to set that back up into exponential form. So this is 10 to the power of 2.1 equals x. And last but not least, x is approximately equal to 1.607. So like I said, this is going to be the preferred method. Less steps here. And earlier I said this is going to be the problem that I would be least likely to give you, a base unknown. I'm definitely going to give you an exponent unknown, and I'm definitely going to give you an argument unknown on the test, all right? I hope this is helpful. Go ahead and cut this out, tape this in your notebook, take some notes on it, put it on your note card if you find it helpful. Come see me tutoring or lunch Monday through Wednesday. Or actually, sorry, I won't be here on Wednesday, but come by. Email me if you need to. Let me know what you need, all right? I'm here to help. Thanks. Bye.